I got in touch with one of the leading green architect firms in Maine, Kaplan Thompson Architects. But we were going to try to really push the envelope for sort of what's the, not state of the art, but what we call the state of the shelf, the state of what's reasonably available, and try to make this a prototype for something that would be practical, affordable, livable, but very environmentally friendly.
And how about that for a client? We don't get one of those very often. He's genuine. He's been true to his word very consistently across the board, that he wants to do this for a greater purpose.
It was about figuring out this question. What does it look like? What does the next level of housing look like in New England?
It's always really exciting and very rare for a client to decide to produce a really super efficient building. I think was a fantastic opportunity, and I really appreciate the opportunity to be part of that and to bring, a number of different minds together to try to solve this problem.
And it requires an integrated approach. So as a mechanical engineer, I have to become more interested in the enclosure. I have to become more interested in other professionals' domain.
The open-built system is trying to connect the dots across the industry to make sure that it all makes sense and each part is connected.
The Collinses and the architects made a real commitment to not only assembling a team, but actually behaving as if they're on a team and looking for everybody's input and taking it seriously.
It is a unique approach, but it shouldn't be. And it's why, quite honestly, most buildings don't work that well. They don't function that well. They're not warm when they ought to be warm, and they're not cold when they should be cold. And a lot of that comes from the fact that they're just very complicated object. They have lots of pieces to them. They take a long time to put together. And you've got to get everyone at the table early.
We all got together. We pinned a bunch of things up on the wall, and they were just words. No images, just maps, just words. As architects, it takes a lot of restraint to do. We've been brewing on this for years. We did a lot of research, but we said, okay guys, don't draw a thing. If this is going to be truly collaborative, let's make it so. We tried to pull in as many people as we could, and we didn't stop at building professionals. We had some people there who were obviously the big minds behind this.
We have several guiding principles that we have gone back to again and again as we try to make decisions about what trade-offs that we're going to make and what are we trying to achieve with the building of the Bright Built Barn. And they are livability, sustainability, affordability, disentanglement, and education.
By the nature of design, what we're doing is going to be compromise. We set up an extranet, so everyone was able to talk back and forth, and there was incredible vibrant conversations throughout the whole process. So when we finished this process, we knew when we came to this building, everyone had their say. Everyone felt good.
I was actually brought in before the building was sited, before the design was complete, before the builder ever brought a machine on the site, and essentially advocated for the landscape in a way to sort of explain this is how this landscape is working, and this is what it will mean for the actual physical reality of this place. If we put it in too awkward a place, are we going to have to wipe out the existing plant material in order to construct this? And I think that the sort of elephant in the living room of the sustainability house is the damage that gets done from conventional construction, building construction. because every project then becomes a restoration project, restoration of the soils, of the plant material. And it is so universal that we don't even question it anymore. You know, the sort of assumption that we'll come back later and we'll fix this, in the same way like our health care. We're going to come back, we don't take care of ourselves, and then we go to the doctor, and the doctor's going to fix us. And very often the role of the landscape architect is exactly that, to come in after a building project has been completed and make it better. And this is not how landscape works. And one of the great things about this project was a recognition that we want to really we want to think it through ahead of time. We want to minimize the damage from construction.
From soup to nuts, from the first scoop of dirt out of that land to the last knob and the last screw and the hardware on the door, everything's been thought of, and everyone's talked about it together. And when that happens, you have something where the whole is greater than the sum of its parts. And I think that's very true in Bright Build.
I was really just looking for a better way to build. And timber framing looked like a good medium, not to repeat the way they did it in the past, but to use modern technology, modern tools, and to apply that technology and those tools to this old building form to make it practical and efficient. And I knew that by doing that, we would have to solve every other aspect of the construction system.
The big question with green building, I think, is figuring out how to integrate the design, the aesthetics, the livability, and the performance.
Any great building, that's the case. But we're innovating here. We're doing something truly different. So there's not so much that's already set in stone. There's not so much history that people have done these things. We're in a new territory here, and that's what makes it exciting.
Basically, this would evolve into a different way to build.
Livability really has to do with the fact that this is a building that people are going to live in or work in. It's not a science project. It's not just a prototype. That this is something that needs to be a practical building.
As people were first grappling with the technological issues of sustainable building and low energy building and appropriate materials, a lot of those first buildings tended to look like spaceships. They had these big glass greenhouses bolted on the side and various machinery on the roof that didn't always quite work, that often stopped working but stayed on the roof. They were seen as these futuristic buildings. At the same time, the space program was in full flight. So that aesthetic has been intertwined with sustainability at some level, and in some sense, when this new green movement we're all a part of, there has been a tendency to reduce it to the equipment and to talk about the things that get bolted on the building.
Obviously, it's not just about structure. And, you know, one of the things we know about a sustainable, durable building, before anything else, they're sustainable because they're loved.
A lot of ideas got thrown at the wall, and a lot of shapes got thrown at the wall of what shape this building should be, what it should evoke in people. And we held very tightly to the word barn and the very explicitness of what a barn is. A barn in New England has a high-pitched roof. It has a 12-pitch roof. It has certain siding. It has certain materials about it. And that's part of all of our collective memory. And we just knew that that was an important piece to hold on to, that it had to stay a barn. One of the major goals was to make it feel like a building that people intuitively knew and loved.
Sustainability, of course, is a major part of what we're trying to accomplish, and it's sustainable in what I would say is a very deep way. It's not just that on a day-to-day basis it creates more energy than it consumes, but that over its lifetime it will create more energy than it consumes, even when you take into account the energy that was used to build it. And that's really pretty unusual these days. In the future, all buildings will be held to that standard. Today, it's relatively unusual. In normal construction, for every 2 houses you build, the waste could build a third one. There's about a 50% waste factor. With off-site construction, you can reduce that to as low as 10% waste, because that 2-foot piece of beam that you threw away on this project, they might need 1.5 feet on something on their next project. And it's still around, it's still in their computers. One of the things that was important to us is not just that it was off-site built, but it was off-site built at a shop which was highly computerized. They have computer wood forming tools, but they also have computer inventory of every piece of lumber that's in there, whether it's a standard piece of lumber or whether it's a piece of lumber that they've cut for another project, and then they can reuse those pieces. So off-site construction was something that we committed to very early, and I think that that's something that is very important to this particular solution for a green building.
Whatever supplies the heat for the building is sized for the peak heat loss, the maximum amount of heat that a building is going to require on an annual basis. That peak can be reduced by 2/3 by doing a good job with your enclosure.
So the base of the system was a 2x6 wall filled with cellulose to about a 3.4, 3.5 pound density. Then what we ended up doing is creating a water barrier, a complete barrier outside of this 2x6 wall. So this is not a little bit of polyethylene, this was ice and water shield. And the idea is that's the structure of the building, that lives inside, everything beyond that membrane is outside. So outside of this moisture barrier is 2 layers of 2-inch styrofoam that is a high density insulation, has a high R value, deals with the elements, is a moisture barrier, provides the added R value that gets us from an R21 up to an R40. The idea of individual panels that could be made as a commodity, taken to a timber frame and wrapping it like a skin. And this very innovative part of the wall, also was a whole concept that outside of that, we would have then rain screen siding. And the concept of rain screen siding is that there's another air film, and the siding itself is also another layer.
It has lots of insulation in its walls. Insulation has no moving parts. Insulation never breaks down. You never have to repair insulation. So this building is a tough building also. It's a durable building, and it'll last the ages just for that alone.
This is a building that's highly energy efficient. It is so energy efficient that even in the depths of winters in Maine, we will have no furnace, no fireplace. There is no combustion whatsoever that will heat this space. It is heated, in most cases, entirely by the sun. We put a lot of thought into the windows. Obviously, this is a super insulated space, but we didn't want it to be dark and feel closed in. So we tried to maximize the amount of windows. The problem with windows is they're great for letting heat in during the day, but they're just as good as for letting heat out at night.
Even the best windows available are terrible with respect to heat transfer.
We had enormous numbers of hours of debate about the windows, how big they could be, because obviously the heat engineers wanted them basically as small as possible. If they could be no windows, they would love that. And no doors, because doors are bad too. So if you could just make a box with no windows and no doors, the heat engineers would be, very well pleased. My wife is an artist. She wanted all windows. If the roof could be windows, if the floor could be windows, if everything could be windows, that's what she would like. We had to come up with a reasonable compromise. So we tried to maximize the insulation value of the windows. And what you'll see is that we have, in the windows, we will have typically a set of clear windows in the middle, which are triple glazed and as insulated as possible, but still not that good for retaining heat. And then above and below, you will have panels of a translucent material, which is actually a very high insulating value polymer, which is translucent, so it lets light in, so you don't feel closed in, but it has a much greater insulating value than glass.
What's really interesting about this building is that the heat loss out of the windows and doors and walls is very, very little. The heat loss through air infiltration is almost negligible because we have a heat recovery ventilator that pulls the heat out of the air that's going out and puts it into the air coming in. So there's two kinds of thermal collectors on the roof. There are the thermal collectors that are tubes. The sun hits the tube and the light energy is converted to heat energy. That heat energy boils water vapor that's in a copper tube, boils it at a very low temperature because it's under a vacuum. That steam rises and is picked up by antifreeze. That antifreeze circles from a tank and a coil in the tank back to the collectors again. So it transfers the heat energy of the sun into hot water. As long as there's heat in that tank, we use that to both heat domestic hot water, and the same domestic hot water is used to heat the space, as long as there's heat in the tank. As soon as there isn't heat in the tank, we have to turn to our heat pump, which is taking heat out of the outside air using electricity in a compressor and extracting that into the space. The other kind of collector that's on the roof is photovoltaic collectors. Those take up more of the surface area and they convert sunlight into electrical energy. What's great about that is the solar electricity that we generate on the roof gets sent back to the grid and essentially stored during the months when we have more sun and less of a need for heat. And then in the few months of the year, the three or 4 months of the year when we have a high need for heat and not a lot of sun, we can pull that electricity back from the grid and use it. We're hoping to see somewhere between a COP, that's a coefficient of performance, of between 2 and 3 in this building. What that means is for every kilowatt hour worth of electricity we burn, we're going to get 2 or 3 kilowatt hours worth of heat. And so the big drivers, it turns out, now are domestic hot water is an enormous amount of energy in this house as a percentage, and human activity is an enormous input into heating the space. So the idea, we hear it all the time, well, you could heat that space with a match. Well, at this house, you could actually heat with just people doing dishes and cooking. In our house, which is a 100-year-old building, we call it the squash furnace. So when it's cold outside, we bake a squash. In this house, you'd have to bake a very little squash.
Disentanglement really relates to the fact that this needs to be an adaptable building. Buildings that are not adaptable have a very limited lifespan.
Commercial buildings are heavily disentangled. Every generic law office has drop ceilings where you can move the wiring around without taking a chainsaw to the walls. And so as an architect, you have this funny switch where you work on these heavily disentangled buildings that are essentially open built in the commercial realm. But when you put your residential hat back on, you go back to these heavily tangled buildings.
That structure, that 2x6 wall filled with cellulose, should not be violated. We're not going to poke it full of holes. We're not going to try to run wires through it or plumbing pipes or heating pipes or anything else.
What really is much more practical is that you have one area where all wiring and all plumbing goes through. And what we decided to do is to put that in the baseboard. The baseboard is something that can be easily popped off, and behind it you have the room for all the wiring and for all the plumbing, so you always know where it is. That had certain interesting consequences for us as we were going along. In fact, you will notice that all of our light switches are on the floor. They're actually foot switches that if you want to turn on a light, you touch it with your foot, not your hand. That just shows how committed we were to disentanglement, so that in fact that the next owner would know exactly where all the wiring was and would not have to smash into walls to try to add a wing.
So you have the intelligence on the inside of disentangling, organizing. You've got a really sustainable structural system. You've got, 2 layers of insulation that provide for the high performance aspect of the wall. And then outside you've got a way to attach rain screen siding. So it really is a creative, innovative approach to a high performance system, but it was all completely done with conventional materials.
Too many green buildings really are sort of very expensive one-off projects which demonstrate the cleverness of the people that build it and perhaps the vanity of the person that financed it, but don't necessarily do much beyond that. If this was going to be something that had legs, it needed to be something that was affordable. And so we worked very, very hard to bring the cost of this within reach of the average person.
While we could innovate, if it was too innovative, it actually couldn't be replicated in too many other places.
We need to practice making buildings like this. And it's through practice that the design profession will change, the construction profession will change.
Our gift, now to anybody who wants it is, here's a wall that can perform at this very, very high level, achieve disentanglement on the inside and on the outside, and have this potential, to perform like this for hundreds and hundreds of years. And, that's the goal of, high performance, sustainable building. If you don't have the longevity, then you don't have sustainability.
We're very interested that people will understand the thinking that we did to come up with this structure, to see the value of the solutions we've come up with, and once they're educated about what our successes and failures have been, we'll be able to hopefully build on that and be able to do their own green structures, building on the base of whatever we've been able to accomplish.
That this isn't ours to hold, this is ours to give. And we want you to take it, and we want you to make a better bright build.
So there's no reason to be proprietary about it. What really makes sense is to find ways to help to educate and transform an industry around the ideas so that we can really, have an effect in the marketplace.
But we don't have a feedback loop on buildings like we do with automobiles. The dashboard is the analogy. We don't have a dashboard for buildings. So there's very little information on how buildings actually perform.
One of the great things about this project is with the different mechanical systems in place, the renewables and the heat pump and all that sort of stuff, with the controls that we have and the monitoring that's going to be done, we'll be able to really get a good picture.
Yeah, one of the things that we felt about this structure is that it should not be inert. It should in some ways be a living and breathing structure itself, and that it should communicate its state. And so we started out semi-facetiously talking about, well, it should have a mood ring. And that evolved, like a lot of other ideas that sounded sort of odd and at start, into something that really became integrated into the whole design. We have a ring of very high efficiency LED lights that go all around the building, and those LED lights change color depending on the energy state of the building. When the building is creating more energy than it consumes, the lights are green. When it is consuming more than it produces, the lights are red. One of the things that we're accomplishing with this building by producing more energy than we consume is that we are paying off our carbon debt. And we also want to keep track of that. So this is, as I said, a building that communicates its state both instantaneously and over time. And all of that will be on the web so anybody can monitor it.
People do expect, to live in an environment that is conditioned. And, we realize now we can't do it by, just burning up the fossil fuels that are, in finite supply. So the net zero, high performing building, has to be the model of the future.